Hello from Esslingen and welcome to Festo's virtual exhibition. Good to have you here. Let's talk about electric automation. Our electric automation product range is designed for easy integration and usage and for fast setup. High performance for higher productivity. If you have any questions, our expert is happy to answer 1, 2, or 3 questions directly after his presentation. For that, please use our chat function in the booth area. And for more questions, we sure have more time after the presentations. Our experts are happy to answer the questions in the live chat. So let's start with electric automation. And Nigel, hi.
Thank you, Dora. Thank you. Hello and welcome. My name is Nigel Dawson, and today, as Dora pointed out, I'd like to talk to you about electric automation, but specifically how here at Festo we strive to bring you seamless connectivity from the workpiece to the cloud. Let's start with our new range of electric axes. These are our simplified motion series, and these simplified motion series are available in many different formats. If you require rotary or linear, guided or unguided, if you require a belt drive or a ball screw, or a gantry style or maybe a rod style, like our pneumatic counterparts in Festo. The range is vast with different sizes, different strokes, and of course different types, as I've mentioned. But what's unique about the Simplified Motion series is, as the name suggests, its simplicity. There is no commissioning software needed for this. In fact, to set this up, all you need to do is install it on your machine, and then using these push buttons that we see here, we can change the speed, the position of the ends, and of course, we can also change the force. And this allows you to install these without a software engineer or a commissioning engineer. And they're very compact. You can see the axes, the motor, the drive, the encoder is all integrated into one solution. We can mount this outside, which means it saves you a lot of space in the control cabinet. And of course, also a lot of time in wiring. But why would you use an electric actuator for simple end-to-end movements? Well, when we consider some of the global megatrends, if you'd viewed the Productivity Master session today, you would have seen we talk about digitalization, individualization, we talk about energy efficiency, and also about demographic change. Then this product looks at every single one of those and addresses some of the challenges. For digitalization, it means that we can connect right down to the workpiece, and we can take that big data via I/O link all the way to the cloud. For individualization, we can use the simplicity of the changeover to actually change a product on the fly on your machinery. For energy efficiency, of course, it's electric, which means it has an advantage when it comes to energy efficiency, and also for demographic change, of course, it means its simplicity will address things like older workforce and less people coming into our industry at a young age. So we use it for all those different aspects, but mainly for digitalization. So we can connect to it using I/O link and of course digital I/O, which means it's very simple. But what if you require more flexibility, more power, or more control? Well, for that, we also have something. Follow me. So, for many years, Festo have been developing a full range of low voltage and extra low voltage servo drives. You can see them here, our CMM-T range. The range is very broad in its power classes, and of course we have extra low voltage right down at 24 volts, and of course low voltage right up to over 400 volts. Along with the drives, we have a matched series of different types of motor, depending on your requirements. Simple low voltage stepper type motors that still work with our extra low voltage servo drive, and of course full blown AC servo motors. But the unique thing about this range is its platform. It doesn't matter whether you're using 24 volts on a very tiny application or over 400 volt 3-phase on a larger motor and a larger axis. This platform remains the same regarding commissioning, software, and connectivity. It's the same Festo Automation Suite commissioning software that allows us to commission a mechanical axis, a motor, a drive, and a motion controller in just 5 simple mouse clicks to get that motor up and running and to check your connectivity. So the platform remains the same with regards to our software. But what about the platform remaining the same regarding what you are connecting to? Of course, we connect this range, as you can see here, to EtherCAT, but we also connect to Profinet, to Ethernet IP, to Modbus, and it's the same platform, it's the same software, it's the same range. Of course, industrial automation isn't just about motors and drives. It's also about other parts of our connectivity portfolio, such as we have over here mechanical axes connected together using our mechanical connectivity. We have all the ranges of motors, drives, and then remote I/O systems. Remote I/O systems connect to all the same networks that our drives do. And of course, let's not forget pneumatics. We have here valve terminals connected on the same network, of course, to all ours and to a new network which I'll introduce you to in a short while. Above the servo drive, you will also need, obviously, control. And you can control our servo drives from the PLC of your choice. We'll have a look at that in practical terms in a second. But we can also control it using the Festo Motion Control Series, the CPX-E. We can do this as a cell on its own, as a discrete small machine. We can do this as part of a decentralized control where this cell is running its own program, but is handshaking with a larger supervisory PLC from a manufacturer of your choice, or from Festo, of course. And more often than not, you will connect our servo drives directly to the network of your choice, and of course to the supervisory PLC, and through the cloud, of course, because we have the IoT gateway, we can connect directly to the cloud with some customized dashboards for monitoring things like temperature. We can monitor the torque, and we can monitor the voltage in the servo drive. We can check for anomalies, and we can run AI, artificial intelligence algorithms, to make sure your machine is running in tip-top condition. So we've looked at the theory of the portfolio regarding connectivity and how we connect our servo drives and, of course, our simplified motion series all the way through to the cloud. But let's go over here and let's have a look now at what that looks like in real life. So here we see a full range of automation equipment from Festo. We have everything from low voltage servo drives to remote I/O systems to, of course, mechanical axes and extra low voltage and low voltage servo drives. If we look at them individually, we can see very simple drives running rotary actuators, electrical stopper cylinders. But let me draw your attention to this new remote I/O system from Festo. It's called the CPX API, and the AP stands for Automation Platform. And that's the network that this is running on between all the modules. It's a lightning fast new AP bus, which allows us to run the cyclic data of your machine and also big data. It's so fast you can even run high definition video over the same network and still not alter your cyclic data and therefore cause problems for your machine. We have everything from digital I/O to analog I/O and I/O link, of course, because we have a lot of I/O link sensors, I/O link servo drives, etc., etc. The system also connects to our valve terminals, as you can imagine. So this valve terminal is also on the same lightning fast AP bus, which means that we can get the diagnostic data right down to the individual valve and do some predictive maintenance on the pneumatics. Of course, in this case, the pneumatic valve terminal is connected to many different pneumatic devices here, and also I/O link sensors linked back via I/O link to here. This system is very flexible. Each field bus or network master can handle 80 different modules with 50 meters between each module without reducing the speed too much, which means that we can cover all industrial automation needs. And finally, we have low voltage and extra low voltage servo drives running, of course, mechanical axes and motors. And finally, at the back there, you'll see our simplified motion series that we started our session on today. This case, this is linked via IO Link directly into our IO system, the CPX API, using the IO Link master through EtherCAT all the way to the PLC. In this case, we're running not a Festo PLC, but an additional PLC from the market, a third-party PLC. But what happens if you have to change the manufacturer of your PLC? Maybe your customer has a different specification, maybe you've moved into a different industry that has a different specification, or your needs change. Well, that's a big changeover for you because the PLC is the main control element of your machine. If we disconnect this PLC from the system, unsurprisingly, everything stops. We probably have some errors, etc. on the system. However, if I connect in a different type of PLC, doesn't matter which PLC it is, in this case we're using a Festo motion controller that we saw earlier, and I press the reset. Under normal circumstances, you would have to parameterize the system, alter it for the different control network, or the different control element. But as you can see here, the low voltage servo drive carries on as normal. The I/O devices, the I/O link, the valve terminal are all operating as before. And the servo drives and the simplified motion series are all doing exactly the same as they did before I reset the system, but this time with a completely different PLC. This is because we believe that your choice of PLC should not hinder your choice of automation equipment. And it certainly shouldn't cause you untold hours of parameterization and reprogramming just because you need to change your PLC manufacturer or your program. Of course, when we look over here, we can see here in Germany, we have to, of course, integrate seamlessly into the Siemens universe too. So exactly the same as we see with other PLCs, we integrate into Siemens seamlessly. And of course, we also can do things like interpolated and synchronized motion using ProfiDrive. So finally, let's have a look at all this on a machine that's actually doing something other than just a demonstration. So over here, we have the Productivity Master. Some of you may have already seen a session on this today. And what this Productivity Master does is it brings every element of things like end-to-end movement using electric drives or pneumatics, low voltage and extra low voltage servo drives, I/O systems, motion controllers, IO link sensors, everything together with mechanical connectivity with our mechanics and our motors without the use of additional adapters to produce a handling system as you see here. Electrical connectivity from our valve terminals on EtherCAT or Ethernet IP or Profinet. Also our servo drives on exactly the same networks and our motion controllers. Between the motion controllers using standardized Ethernet protocols like OPC UA, through our IoT gateway, and this is directly linked to our cloud service here, through our IoT gateway to the cloud, not just to push data up for diagnostics and preventative maintenance, and of course, artificial intelligence, but also to pull information down for individualized production, so we can create a lot size of one economically. So when we bring all those factors together with the Festo electric automation portfolio, you can see that we can bring you seamless connectivity from your workpiece to the cloud. Thank you very much.
Thank you, Nigel.
Hey, Dora.
And as expected, we have many questions, and we would love you to answer 2 of them now, live.
No problem.
And the others
No
will be
problem.
answered
I
in
hope I
our
can
live
answer
chat I'm sure you can. You're the expert. So, Nigel, the first question we'd like to focus on is, how do the simplified motion series actuators compare with the cost of pneumatic installation?
Very interesting question, because as you can imagine, with a motor or a ball screw, etc., it's a little bit more expensive to buy the actuator than a traditional pneumatic cylinder. But of course, we're not really comparing the same. A pneumatic cylinder requires a valve, fittings, tubing, setting up, flow controls, air preparation, a pneumatic installation. When you add all that together and compare it, it becomes very close in cost. However, that's not the end of the story, because when you think about the installation of this, the fact it requires no software and you can get data all the way from the workpiece up to the cloud seamlessly, which you can't do with a pneumatic cylinder, then of course it's the feature set that makes it the more cost-effective solution.
Thank you. And the second question is, why do we need electropneumatics when pneumatic automation is there?
Oh, very good question.
Damn.
Yeah. Okay. Of course, we need both.
Yeah.
Yeah. We don't want to replace pneumatics, because pneumatics is very good for very high power density and also miniature devices. We don't want to replace them. But I mentioned earlier individualization as a trend in the marketplace. That means we need to be able to produce machines that can not just mass produce 1 million parts, but produce a lot size of one economically. And for that, you need adaptive control. You don't need to go from A to B. You need to go from A to B and stop at C, D, E, and F with different speeds, different accelerations, etc. That's why we need both electrical automation and pneumatic automation to offer a portfolio that is technology neutral.
Nigel, thank you very much for the insights in this field. Thank you for the great questions. And stay tuned till our next session, which is about the highlights in automation. This session will start in around about 10 minutes, so we hope to see you there. Thank you and goodbye.
Thank you.